Welcome in, everybody. Hope you all had a good day so far. We are kind of ahead of schedule, so it's going to be kind of a chill day today. We're really just going to be talking about some string manipulation. This is another type of variable that are not numeric. A couple of days ago, in the previous recording, we were talking about numbers. All we really did was use some integers, some doubles, and did some arithmetic with it. But today we're finally gonna do a different type, a non-numeric, with strings. So it's gonna be a pretty short day today. This is a very small topic. Uh, we'll end off talking about the Jshell. This is a tool that came with our environment. You might remember on day one, we installed something called JDK. We installed JDK, which stands for Java Development Kit. Let's see. And one of the softwares this comes with is something called Jshell. So this is a very useful tool that will help us debug and learn small things in Java. So we'll do that in a bit. We'll also have a class exercise as well. This exercise is going to be very similar to the next programming project. Next programming project is going to be some sort of write a program to take inputs and calculate something from it. So it's gonna be similar to this. All right, people cool with this so far? Any questions about the future of this class? Let me take a look at the weekly schedule. Yeah, we're pretty much ahead of schedule. So next week we'll cover some if statements. Okay, let's continue then. So we left off on a class exercise. This class exercise was right here. The whole point of it was to get folks set up on how to do like a free response question. You can think of this as a free response exam question maybe. Or these are also in the readings too. If you take a look through the readings, they're going to have a bunch of interactive exercises that's going to look similar to this. So yeah, we did this on a couple days ago. Feel free to take a look at the previous recordings. I also uploaded this possible solution on Canvas, so you can find it on Canvas Canvas files over here. Let me show you. So you can go into files here in the Canvas, and then there's an examples folder, and then area of a circle is right over here. I would suggest sorting this folder by last modified. Right now it's in alphabetical order. If you're sorted by last modified, it'll show you what we did most recently. So I'm gonna sort it by last modified, and yeah, area of circle. That stuff on top should show up. Okay, let's continue then. We also summarized what type of errors we can see. We talked about syntax errors, which happens during the compiler, and then there is runtime exceptions, which happens during the execution of the program. And finally, you can also think of logical errors. These are kind of harder to see. The logical errors happen during the execution of the program, but the computer doesn't really know about it. I think the human knows, because an example of a logical error is if your program miscalculates something and then the output turns out to be slightly different than it should have been. So we'll see a lot of logical errors soon. Next week we'll talk about if statements and writing Boolean conditions. So that's going to give us quite a bit of room to do logical errors. All right. You might be wondering, how do we protect against these errors? Well, I'm going to give a sneak peek into this. We're not going to talk about how to mitigate these yet. We need to cover some more content. But we saw a bunch of errors that can happen. Runtime errors during the execution. Like, for example, let me go ahead and invoke a runtime error real quick. So I'm going to load up VS Code. Okay, here's my VS Code. The most recent one we did was called area of a circle. So here's the area of a circle. I'm going to go ahead and let's see. I'm going to go ahead and compile and run this. So let me pull up my terminal. Okay. Cool. Let me go ahead and compile this. Compile and run. Java. Area of a circle. Oh, I'm in the wrong directory. I'm in the root folder, the CS-12J. So I need to go into examples. Okay, let me cd into examples first. So cd into examples. And then if I do an ls, I should see it. There it is. I see it. And then I can go ahead and Java area. You can press tab, by the way. Tab is an autocomplete. And it should fill in the rest of it. Okay, so tab. And then I'm running the program right now. I'm just going to run it normally for now. So if I type in a radius like 5.4 or something, enter. This does work as intended. You could double check this on a calculator. I'm pretty sure it's... Oh, no, it's not right. It's not right. This is actually a logical error right here. The area of a circle is not 16.96. This is a logical error because the computer didn't really catch it. We kind of had to catch it. So the reason here is just the equation here. I forgot to update previously. The area of a circle is pi r squared. This one is only doing pi times r. So we got to square the radius. Okay, and then there we go. Now that should fix our logical error. So I'll go ahead and test it again. 5.4, 91.6. I think this is more correct. I think. Okay, so let's talk about a runtime error that can happen. Let me rerun the program again. The program is currently stuck on this line here. It's waiting for input. So if I were to type in something like a string, if I type in like idk, this is a line 8 is going to finish, but we're probably going to get a runtime error here because a user input is the literal idk. This is being passed into a method down here, and I'm pretty sure the method is going to fail because the goal of this method is to convert a string into a double, a decimal. But in this case, idk, there's really no way to convert this into a double. So let me press enter. I'll press enter, and we get a runtime exception. This once again happens during the execution of the program. This is kind of like a stack trace. A stack trace traces through different methods on where it might happen. In this case, the root of the stack is kind of like right here, line 9. So yeah, we see that it failed right here. So this is an example of a runtime exception. When the reason it happened is because we didn't validate the input. This is going to be something we'll have to talk about next week or in the future. Some ways we can protect our program is by making decisions. This is once again next week. We'll talk about if statements. We can first check the input. We can validate the input, determine whether or not determine whether or not it's valid, and make decisions based off there. If it's not valid, then maybe tell the user to do something else. If it is valid, then continue with the rest of the program. So we'll talk about making decisions next week. There's other ways you can do this too, like exception handling. Java is a language that's really good at exception handling. There's something called try-catch statements. This is a little more advanced topic. We'll probably cover this towards the later end of the semester. But if you want to take a look at the future, this is in the 11.3, the reading. Okay, but yeah, the point is there's a lot of room for error during input. When you deploy a program or software, it's usually good to assume the user will make mistakes. So by assuming the user will make mistakes, you'll have to make the program more robust. meaning to protect the program from crashing. We saw earlier this runtime exception. This crashed the program, meaning that future statements cannot run. So this can be considered expensive. In the future, when you're developing like industrial software, the more your program crashes, the more expensive it is. So it's good to assume the worst and make the strongest program possible, in my opinion. Okay, but yeah, these are just sneak peeks. All right, I wanted to jump into this class exercise, and then after that we won't do numbers anymore. We'll work on strings. Okay, so class exercises are meant for folks to do in class, actually. This is my first time teaching Java hybrid, and most people are watching this online, so on YouTube, I mean. So I would recommend pausing the video when you see this problem, and then attempting it yourself, but before seeing the solution. So yeah, once again, go ahead and pause the video and try it out. This is a good practice for free response questions on the exam, or your programming projects as well. These are just applications of what we covered previously. Okay, so yeah, the goal of this class exercise, we'll see a problem, and then on the right we'll see expected output. Expected output is kind of like the answer key. It'll tell us what's the expected behavior when we run the program. For example, if you were to finish your program and execute it, the expected behavior should be something like this. The program should output miles traveled, and then take in some input. So in this case, 30 is the input. So the user will type in 30 and then enter. And then next line, the program would output gallons used, 2. And the program should do something with those 2 inputs and calculate some sort of output here. So in this case, it's 15 miles per gallon. We're calculating efficiency, by the way. Efficiency is defined as miles divided by gallons. Miles per gallon. Okay. Here's another example of the test case. 100, 3.5. If you divide them, then you get 28.57 miles per gallon. Okay, I just want to give a quick motivation on this exercise real quick. Just some context. For folks who drive cars, let me pull up a picture real quick. Let's see. Let me just pull something up real quick. Okay, I'm trying to find a picture of the dashboard. Can't really find one yet. So let me see. For folks who drive a car and have a dashboard, there's a chance that the dashboard might have a dial that shows miles per gallon. So here, this miles per gallon right here, this tells us the efficiency, the current efficiency of the car. And let me pull up another picture actually. So I drive a different car. Let me pull it up. I drive a Toyota Camry. Let me see if I could find it real quick. Okay, I found a picture. This looks like the dashboard that I drive. It's a Toyota, but the point is there is a dial here on the bottom right. So on the bottom right, this dial is miles per gallon, and it's currently at 20 miles per gallon. If the driver were to drive a little more efficiently, then this bar would move a little further up because they're getting more miles per gallon. So yeah, this dial you can imagine as there's some background program maybe that calculates this dial. In order to calculate the MPG, it requires two inputs. So the car is recording how many miles are being traveled, and then is also recording how many gallons are being consumed. So the car uses those two inputs to constantly update this dial here. So yeah, that's pretty much the point of this class exercise. We're emulating this bottom right dial. If you have this, some cars have it. Okay. Cool. So let's go ahead and give it a shot. I'm gonna go ahead and do it right now, and explain the thought process along the way. So I'm gonna go in VS Code here and create a brand new file for this. I'm gonna call this file efficiency. No, I'll call it efficiency. Car efficiency. Yeah, I'll call it car efficiency.java. Okay. Cool. There's our empty file. Let me set up the boilerplate. Once again, boilerplate means this will make sense later. Just focus on the stuff in between these curly braces. Okay, so the first step here is we need to prompt the user for an input, the miles traveled. So I'm gonna go ahead and start off with a print statement that prints miles traveled, colon, and space. So let me go ahead and get that. Okay, print statement. I'm not going to use a print line. I'm going to remove this line. The reason is so the input can show up to the right of it. If I were to have the new line, then our input would be on the next line. So I'm going to get rid of that new line there. It's going to print miles traveled, colon, space. And then I might as well get the input over here. So the input you saw last week, one way we can do it is by using this method called io.readLine. This is a method that returns a string, meaning that it's probably useful to store this in some sort of variable. So I'm going to store it in a string variable. I'll call it like a user input or something. I'll call it user input. Okay, cool. So I just stored it in one line, and then let me go ahead and test it actually. So I'll go ahead and save, and let's test it. So Java car efficiency. I'm gonna tab complete it. So I just press tab, enter. Okay, let's test this real quick. So I'll type in 30, and then enter. Okay, cool. There's program is working as expected. There's no crashes. Let's go ahead and continue. Okay, next we need to prompt the user for amount of gallons used. So let me go ahead and get that. io.print gallons used. Okay, and then I'm gonna take in the input over here. We can reuse variables, by the way. You don't have to recreate a variable every time, but I'm gonna recreate it just so folks get some practice here. So, oh, you know what? I think this is actually a bad name here. Over in line 3, user input. This is kind of a not descriptive. I'm gonna rename it. Let's see. I'll just name it to miles traveled. Okay, this is a better name for the variable. And then gallons used here. Okay, let me just test these two real quick. So we have two inputs. Let's test it. Okay, so I just ran it. Miles traveled. Let's go 30. And then let's say we use 2 gallons. Enter. Okay, great. We have the first 2 lines done. And now all we have to do is use those two variables and calculate the result. Once again, efficiency is defined as miles divided by gallon. So all we really have to do is divide miles traveled and gallons used. However, I do want to mention that these are strings. In different types have different operations. In Java, it doesn't make sense to divide strings because strings are literal text. So if you were to try to divide those two variables and store them into something, you're probably gonna get a syntax error, like a illegal grammar error. So here, let me just test it real quick, just to show folks what error will happen. So if I attempted to divide miles traveled divided by gallons used, first of all, this statement doesn't really do anything. I'm just stating a calculation. It's probably useful to store it into some variable. But if I were to run this, I get a not a statement. So this is what I was saying earlier. You have to store this into something. So if I were to store this result into some variable, like maybe a double, because divisions can have these decimal points. So if I were to store in a double, like efficiency is equal to miles traveled divided by this, we're probably going to get an error here because we're attempting to divide strings. So let me run it. Okay, I got an error here, but it's not the error I was looking for. It's saying cannot find symbol mile traveled. I have a typo here. I meant to do miles traveled. So let me put miles here and then save and rerun. Okay, rerun. Okay, this is the error I was looking for. So the compiler is pointing at line 8. It's telling us bad operand types for division. And it's telling us the first type is a string and second type is string. So in short, the compiler is saying we're not allowed to divide strings in Java, but we are allowed to divide doubles. Doubles mean decimals. So we need to find a way to convert these strings to a double. There's many ways you can do this. One way is by using a method from the double library. You saw this last week, but I'm gonna pull up this library. So I'm just gonna Google up some primary documentation. I just Googled up the double class in Java. Okay, so we're gonna take advantage of this method somewhere down here. Okay, this is a little hard to read right now, but by the end of the class, I think you should be able to read most of this stuff. I'm looking for a method that converts a string to a double. There's quite a lot of methods here. I believe the one that converts it is called parse double, I believe. Let me let me control F this. Control F lets you search through parse double. Is this one? Okay, let me just read this description real quick. Returns a new double that's represented by a string. Okay, cool. There is a method that converts a string into a double. It's called parse double. So one way we can use this is by, well, you could do on the fly. You could just wrap this string inside of that method. You could say like a double dot parse double. So this thing that I highlighted, all I did was put the string inside of the method. I'm gonna do the same over here. So double dot parse double. Okay, there we go. Just did it for the numerator and denominator. And let me go ahead and test it real quick to see. So let me go and compile. So Java. Okay, cool. No more syntax errors. Great. So our program is now running. Let me go ahead and test it. So I'll go 30, enter, 2, enter, and there's no more output here. because we forgot to output the efficiency. Okay, let's go ahead and output the efficiency, and hopefully we get the correct number. Okay. Cool. Let me pull it up over here. I'm gonna print it out exactly like this. So it says your car's efficiency is 15 miles per gallon, or something miles per gallon. Okay, so print line your efficiency car's efficiency is some number. So in this case, the number is efficiency. Here that I'm concatenating strings, by the way. Concatenating means this double was being treated as a string because the left side is a string. So we're adding strings, and then I'll add another string here. Space, MPG, and then period. Okay, so space, MPG, and then period. Great. So let me go ahead and test this now. So Java, and then let me go 30. Whoops, I made a typo here. Check this out. I'm probably going to get a runtime error in just a bit. So I made a typo and typed in an apostrophe here on accident. What do people think might happen? Let's see. I'm going to type in 2 here. So 2 and then enter. And it looks like I got a runtime exception. So the runtime exception, it happened on line 8. Line 8 is right here. And in particular, it failed for input string 30 apostrophe. So it's failing over here on the numerator. This method is failing because I accidentally put an apostrophe, and the method doesn't know how to convert that to a number. So let me go ahead and rerun it. Okay, Java. Okay, rerun. Let's go 30, enter, 2. Okay, sweet. So we got this. The car's efficiency is 15.0 miles per gallon. This looks about almost right. Yeah, it looks pretty much right. Just our decimals are off a bit. We'll fix the decimals in a bit. But let's go ahead and test this next case. This is another example. So let me go ahead and run 103.5. So let's go 103.5 and then enter. So enter. And our output 28.57 something. Yeah, that looks about right. 28.57 something. If anything, we should probably output it to 2 decimal places. In a lot of programming projects, you'll see that they're being automatically graded. For this class, I'm not really doing full automated grading. I'm kind of reading it and making sure the style is all good. But in future classes, there's a chance that it's 100% auto-graded, meaning that any characters will count. Like this output is slightly off. Whoops, hold up, let me resize these screens. This output is slightly off, so if you were in a class that had 100% auto grading, it would count this as incorrect. So it's sometimes necessary to be exactly matching this expected output, exactly matching to the spelling, the spaces and punctuation and all of that. So here, let me go ahead and format it to 2 decimal places. One way you saw how to do this is by taking advantage of this other function called print format. So you saw this in the area of a circle. If you want to take a look at the last class's material, you might remember this system.out.printf. This is a more powerful function because it allows us to format within strings. Lately, we've been using I/O. This is a new feature in Java. I talked about this in the very first week in class, but in our brand new version of Java 25, there is a I/O library which pretty much wraps the system.out object. So they're almost the same, except system.out has a bit more power. So I'm gonna go ahead and use that over there. If you're curious what I'm talking about this over here. So if you look up the IO library in Java 25, let me pull it up. Is it this one? Yeah. Yeah, so this is a brand new class in Java 25. There's only a few methods that we can use in that library. Print line, read line. There's not really a lot of power here. But if you take a look at the documentation here, you'll see that all this class does is wrap a object called system.in or system.out. So if we were to look at the system.out, we'll see a function called printf. Printf is right over here. So this is a method I'm going to take advantage of, which will allow us to format within strings. It's pretty useful stuff. Okay, so let me go ahead and use that to format. So system.out.print. I'm going to do printf instead of print line. So printf. And you know, before I even format it, let me just do the same exact behavior up here so people are aware. So you can say something like your car's efficiency is something miles per gallon. So something, I'm just gonna put like a space here for now, like a asterisk, just temporary placeholder. This is temporary. MPG. Okay, so I'll save it real quick. Let me test this. So 30 and then 2. Okay, cool. So our second print statement is almost right. The cool thing about this print format function method is we're able to substitute things inside of the strings. This uses a mini language. I'll pull up the documentation in just a bit. But in short, you can put a %s here. A %s means this piece will be substituted. Oops. This piece will be substituted by a string. In order to substitute it, we need to add some more arguments to this method. Arguments are inputs to a method. So far we only have one argument, but now our second argument over here, so comma space, will be what we're substituting. So efficiency is an argument that will be substituted into this %s. Okay, let me go ahead and save it real quick. Save, compile. Okay, 30 and then 2. And you see how it says 15.0 here? Yeah, so these two are pretty much the same now. If anything, we need to format it. So I made a small mistake here, kind of on purpose. But strings, we're attempting to format to do decimal places, and with strings you can't really do that. We would have to treat this as a float. So I'm gonna put like a .2f here. I'll explain what this means in detail later. But in short, this says we're going to round to 2 decimal places and treat it like a float. A float is a decimal, by the way. Floats and doubles are pretty much interchangeable. It's yeah, floats and doubles are pretty much interchangeable. It's just that doubles have more range. But you can treat it as a float here. And if you were to go ahead and run it, so whoops. So let me go ahead and save and then run it again. Go 30 and then 2. And then yeah, we see that the second print statement is rounding up to 2 decimal places. Let me go ahead and test it with a different case. Let's go 100 and 3.5. Okay, let's test it again. 100 and then 3.5, enter. And there we go. We see the second print statement is a little cleaner. So I'm gonna comment this out over here. Okay, let me just check on the Zoom chat real quick. Okay, people doing okay, nice. All right. Let me test this one more time. So 100, 3.5. Okay, cool. Looks like we completed this class exercise. Let me quickly point out some documentation for this. You don't have to know too much about this because you can always refer to the docs or look it up. But this percentage .2f, this is like a mini language that exists in a lot of other languages too. So this is not just Java. This works in C. This works in Python as well. If you want to look it up for Java, you could Google up string formatters in Java. And then the primary documentation lives right here. So let's see, primary documentation. This is, this should be fine right here. It is a little harder to read right now, but if you scroll down a bit, it'll kind of explain what all of those symbols are doing. Like, what is the percentage? The percentage specifies that the future is going to be some sort of formatter. And then we use the F. We use F here. It means that we're going to format as a decimal number. And yeah, if you want to take a look at some more detail, this is the syntax for formatting things. Okay, this is just one way on formatting, by the way. You could also use the math library and probably round to 2 decimal places. In this case, I'm not using the math library. I'm using the system.out native things. Okay, so yeah, that's pretty much the class exercise here. I'm gonna try to have a class exercise almost every other lecture, maybe every lecture, so folks can stay on top of it. But yeah, once again, whenever you see a class exercise, and if you're on a recording, please go ahead and try to pause it and attempt it yourself. This will give you room to see possible errors. If you were to just continue the video and copy down the solution, it might ruin creativity. It just depends. But I suggest trying it out yourself and running into errors and trying to fix it yourself. This way you'll have better problem solving skills. You'll have better abilities on troubleshooting, and you'll get better at reading primary documentation as well. Okay. So yeah, that was the class exercise. Any questions about this so far? Okay, cool. Let's briefly talk about strings. This is another data type, another type of variable. And then we'll end class off on the Jshell. This is a very nice tool that we'll talk about. Okay, but for the strings, I'm gonna kind of briefly scrape the surface here, just kind of introduce what these things are. There's some reading. The reading does have a sneak peek into the future. If you were to take a look at it, there's going to be some stuff that we haven't covered yet. Like let me scroll down a bit. They're going to go over if statements and else statements. We haven't covered this yet. I am doing things a tiny bit out of order, but this should give you a nice sneak peek into next week. Next week we'll talk about if and else statements. You'll see some stuff on loops, I believe. Let's see, let me scroll down. Yeah, scroll down a bit. You'll see them doing something with a string. They end up splitting the string and then looping through it. So this is called a for loop. We'll talk about for loops in 2 more weeks. But it's a good idea to get exposed to this. So when you see it in a couple weeks, it'll come together a little better. So yeah, highly suggest looking through the reading. It's going to give a lot of sneak peek into the future. All right, but for here, I'm just going to briefly scrape the surface here. Let's talk about some string manipulation, and which are not numbers. So I'm going to go ahead and exit all of this and create a new example. I'll call it string manipulation .java. So string manipulation.java. The point of this is just to scrape the surface and introduce what strings are. So yeah, this is gonna be a very short one. Okay, and it's a good reason it's going to be short because we're going to end up using the Jshell later, and you'll see that we can do things a lot faster there. Okay, so Java string manipulation.java. Let me go ahead and declare a string variable. So in Java, it's with an uppercase string. Let's say I name it like I'm gonna name this variable like text. I'm just gonna keep it super general. So string text, and then I'm just gonna save it right away. I am gonna take this a little slow just to be more detailed. This line of code is telling the computer, hey, I need some memory for a string. So we grab some memory for the string, and then now we can go ahead and fill it up if you want. You can take it from input if you want. I'm just gonna go ahead and hard code it, just so we can be a little quicker about it. I'm just gonna hard code like hello world here. So you could take it from user input and make it a little more general. This is hard coding, by the way. Do people remember what hard coding means? Hard coded data means that the data lives in the source code. So if we were to run the program every time, the values would remain the same. So yeah, hard-coded data. I'm going to leave it as this for now. There's a bunch of things we can do with strings. If you take a look at the documentation here, I have a link. It's going to go through a bit of what strings are. But I wanted to point out a few methods that you might find use in. In particular, let me scroll through here. Oh, there's a lot of methods here. Let's keep it simple and maybe use this first one. So this is a method that allows you to look at single characters at a time. What's a character though? We haven't really talked about characters. These are like pieces of the string. A character is like you can think of it as an individual letter. It doesn't have to be a letter though. It could be a number, it could be punctuation. But yeah, that's what a character is. So this string right here, how many characters are in it? Well, you could count it individually. You could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 characters in here in total. I did include the space. The space is counted as a character. So yeah, you could count it, or you could take advantage of another method. I believe there's a method that tells us the size of it. So let me scroll through and see length right here. So there's a method called length. This is going to return an integer that represents the length of the string. So the way we could use this is by doing something like text.length. So text.length with these parentheses here. This is called invoking a method. However, this doesn't really do anything. If I were to compile this, so Java string, it doesn't really do anything because this is kind of like a floating number. It's like if I were to put like a 12 here. You see how I put 12 and then semicolon? That's kind of like what's happening here. 12 doesn't really do anything. It's just floating in there. So yeah, these two are pretty much the same. It might be useful to store this return value into a variable. It might. The reason is because this method returns an integer, and you might want to use that value for the future. So you could go ahead and store it into some variable. I'll name it. I'll store it into an integer, and I'll call it size or something. So once again, the right side gets evaluated first and stored to the left. So let me go ahead and print out the size. Size of string is, and you know what? I'm gonna put this here, size, and let's see. Let's sanity check. Hopefully it prints out 12. So Java, and yeah, there we go. Size of string is 12. Okay, it's always going to be 12 because I hard-coded data. Okay, but if you wanted to generalize the program a bit more, you could take input instead. All right. What are some other things we can do with this, with the strings? As you saw, there are tons of things we can do with strings, and we'll talk about some use cases later. But let's talk about another one. This character at this first one here. This is a method that allows us to extract single characters at a time. It does take an argument. An argument is an input to a method, and this argument represents what position to grab it at. So if I wanted to grab the first letter, then we could just say text dot char at 0. Okay. I do want to mention that in a lot of programming languages, the first position is usually represented by 0. So yeah, 0 is the first position, and this method does return something. It returns a character, so it might be useful to store this if you're planning on using it later. I'm going to go ahead and store it, the result of this method. So I'm going to store it in a character. I'll call it like letter, because we're extracting letters. All right. Okay, cool. So we extracted the letter. Let me go ahead and print it out real quick. So I'm just going to print. I'll say the first letter is. I'll just put letter here. Okay, let me go and test this. So save, and then can I clear this? Let me type in clear. Okay, cool. I can clear. Okay, sweet. Let me Java, and okay, I just ran it. Size of string is 12. The first letter is H. Yeah, that looks about right. Okay, so yeah, hopefully people see how to grab the next letters. You could grab the second letter, which is represented by 1, because we start counting from 0. What about the last letter? Well, we could get the last letter just by counting, and like here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it looks like 11 is the index that represents it. So you could put 11 here. I'm going to change this in just a bit because it's kind of not general enough. I'll explain that in just a bit. So I am going to store this again in letter. So I'm reusing a variable that I declared earlier. I'm reusing it. So let me go ahead and print it back out. io.println. The last letter is. Okay, let's test this one right here. So save, compile, and run. And then yeah, the last letter. Well, it's not really a letter. It's more of a character. So you know, let me just change this vocab a bit. The first character is, and then char. This is kind of a bad name too. Letter. I'll just leave it. It's whatever. Hopefully people get the point though. The first character is H. Last character is exclamation mark. Okay, I do want to mention that this 11 right here it's kind of hard coded. You can consider this a magic number. So 11 is a magic number. Magic number is like a literal that lives in your source code, and some people might not be sure what it represents. But people are going to be like, oh, what's 11? No idea. This is also kind of a bad programming practice, because if our data were to change, then we would get a logical error down here. Like, let's say I were to just put my name here. Like, let's say I put Andrew space tech. Okay, let's see what happens then. So I just changed the hard-coded data, and then now, oh, okay, it's actually correct. I got lucky. I got lucky here. People see what I mean by got lucky. My full name happens to be the same size, so 11 still grabs the last character. Let me put another text here, like welcome to Java. So this is another text. Let me test this one, save, and then yeah, size of the 16. First character is W, that looks right, but then our last character is J. This is not correct. It should have been an exclamation mark. So one way we can mitigate this is by representing the last position more generally. One way we can do this is by getting the text length -1. So instead of 11, you could represent this as text length -1. I know this might be a little hard to read right now, but text length -1 is an integer that represents the last position in text. This -1 is there because we start counting from 0, so we're kind of offsetting a bit. Okay, so let me save this and test it, and yeah, there we go. We finally have the exclamation mark here correct. Okay, cool. So yeah, hopefully people kind of getting a sense on what some good programming practices are. Typically, we would generalize code so it can handle all sorts of problems. In this case, we do have hard-coded data, but if you were to change this to take input instead, then there should be no logical errors down here. It should still represent the correct answer. All right, yeah, so pretty cool stuff. We're just scraping the surface on strings. Just scraping the surface. We're talking about characters, like individual things inside of a string. And we talked about the length of it. There's a bunch of things you can do here. Let's see. You might be wondering what's the use cases of strings. For now, we're pretty much analyzing text. I think in a future assignment, like maybe 3 weeks from now, there's going to be an assignment that deals with bioinformatics, like DNA sequences. Here's what I mean right here. Let me pull up a picture. DNA sequencing. All right, so I just looked up on Wikipedia DNA sequencing. This is a useful application of strings. You might remember in high school or biology class that DNA sequences is part of genetics, and they consist of 4 molecules. You don't have to know these molecules, but they are represented with these letters over here. Let me just pull this up. So these letters here represent the molecules in each of those, the DNA helix. Here's what I'm talking about, the DNA. Let me just pull up a picture. What's a good picture here? This is kind of a good picture. Okay. Yeah, so the DNA helix is like a ladder, and each molecule or protein, but whatever. I'm not a biologist, but each piece can be represented by a character. Like this red right here, I think this stands for some molecule, and it's T. T is short for timing or something. And then there's A, this is another molecule. C, this is another one. So yeah, DNA sequences can be represented as strings, meaning you can calculate certain genetics. You can calculate certain things by going through the string and maybe counting things. So yeah, that's kind of a good use case for strings. But we do need to cover loops though. We haven't talked about loops yet, but loops is a thing in programming that allows you to repeat. So in a few weeks, we will write code to iterate through a string, meaning we'll write some code that's gonna take a string and look at every individual character. It's gonna look at every individual character and then do something with it. So yeah, stick around for that. Stick around. But yeah, I just wanted to introduce some strings to folks. We're just scraping the surface. We'll see more in the future. Any questions about this stuff so far? Oh, let's see. Oh, someone in Zoom chat, let's see. Is hard-coded and constant the same? Oh, Loot Fun. Is hard-coded and constant the same? Sometimes, yeah, so sometimes it is the same. For example, in the area of a circle.java, we made a constant and hard-coded it to 3.14159. So this is hard-coded and constant. But sometimes they're different. Like this could be constant and not hard-coded. If I were to not hard-code this, I would remove this number here and pull it from somewhere else. So instead of hard-coding 3.14, I could pull it from a library. I forget what library is called. It's probably called math, and then you could do like a .py or something. You'll probably have to look this up, but this is an example of a constant that's not really hard-coded. Thanks for that question, Lootfun. I didn't see it until now. Okay, cool. Let's continue then. Okay. All right, no problem, Lootfun. No problem. Okay, cool. So yeah, we're just scraping the surface on strings. Let's finish class off by introducing this Jshell here. This is going to be some pretty cool stuff, actually. Some folks might have come from a Python class. If you did, this is going to be very familiar to you. A Jshell is a command line interface that will allow us to visualize like small tidbits of code at a time. So this is useful for debugging things. Like let's say you were to have an error on some line. It might be useful to narrow it down, and you can use this tool to narrow it down. So here, you know what? I'm gonna go ahead and pull this tool up real quick. This came installed in the very beginning of class. The very first day of class, we installed JDK25, which came with a compiler, it came with a runtime, and it also came with Jshell. So let's go ahead and load it up. Go ahead and pull up your terminal. So my terminal, I'm on Windows, so I'm gonna load up PowerShell. If you're on Mac, just the terminal. And you should be able to type in Jshell here. So I'm gonna go ahead and type in Jshell and then enter. So Jshell and then enter. Okay, cool. So I just loaded the Jshell. You should see this and then this arrow key here. This is a command line interface that is a REPL. A REPL stands for read, evaluate, print, and loop. This really just means like a calculator. You can think of it as a calculator where you type in expressions, press enter to visualize it. So for example, let's say I did like 1 + 1. Okay, so when I press enter, the command line will read it, it's going to evaluate it, and then it's going to print the result. And then it's going to loop back to input. So it's going to do all of those. So I press enter, it did all of them. It read, evaluated, and then it printed the result here. And then now we looped back to input. So yeah, this is good for like visualizing small tidbits of code. You could do string stuff as well. Like let me do string concatenation. Hello plus world. So hello plus world, this gives us hello world here. Maybe you wanted to test something else, like is it possible to divide two strings? So is it possible to say, hey, what is hello divided by world? No, it is not possible to do that. We get a runtime error. You saw this earlier, probably like half an hour ago. This is saying we're not allowed to divide strings. Okay, or maybe you wanted to use the Jshell to test variables, like maybe you're investigating 5 divided by 2. Okay, so this is kind of a review from a long time ago. So we are using the Java language still, the Java syntax. 5 divided by 2 gives us 2. Kind of weird, right? This is review from last week, but this is integer division happening. Integer division seems like a bug, but some people consider it a feature. Sometimes it's necessary to ignore the decimals. So, if you wanted to treat this as a decimal, you can just change one of the numerator or denominator to a double. And the easiest way is by using a 0.0. This is saying, hey, use a float or use a double literal, and this will give us 2.5. So you can kind of use it as a calculator. You can also declare variables inside of Jshell as well. Like if I were to declare like a string, so I'm declaring a string text is equal to let me say I'm just put hello world. So string text is equal to hello world, and then let me go ahead and press enter. Okay, cool. Evaluated. All this line did was store text in memory. So we have memory that stores this over here, and if you wanted to, you could print it out again, like io.print text. You could do this, and then it just prints it out. You could play around with it. Like you could say, hey, what is text.char at? What is text.char at for? This is a good exam question, by the way, folks. What is the return value from this expression? It's you'll see this on the exam. So if you want to predict it, what is it? Oh, well, it's a 0. We start counting from 0. 1, 2, 3, 4. So it should be O. And yeah, it looks like the method is returning O here. Okay, don't worry about this stuff over here. This is just the history, and it's showing us that this is the 7th command that I ran. All you really got to focus on is this part here. It's showing us the return value from the expression. You can do a lot of stuff with this. What else? Let's see. You could play around with string methods too. Like let's say text is equal to something else. So I'm gonna overwrite text because currently text is equal to hello world, but I'm gonna go ahead and overwrite it, meaning it's gonna be something else. In the future we'll be doing some data analysis. Like let's say we're analyzing data, string data. Maybe the string contains names like Andrew, Bob, Charlie, David, Emily. So let's just say I declared a string that has some amount of names. So there we go. I have text here. Text is just this over here. Sometimes it's necessary to test out methods before using them. So Jshell is kind of a good playground to test methods. One method I wanted to point out is this over here. Let me pull it up. So I'm in the string class for the documentation. I wanted to point out this one we'll see in the future. I think it's called split. This is a pretty good method, actually. Yeah, there's a method here. It's called split. You're gonna see this in the reading, by the way, in the 3.4 reading over here. So this is the 3.4 reading. You'll see this down here somewhere, the split. But basically the split allows you to cut pieces from a string based off of whatever character. In this case, maybe you wanted to separate this single string into a bunch of strings. So you could do that by saying split. So I said text.split. I'm using this method over here. And then the argument, the input to the function represents the character to split on. So I'm gonna do a space here. This says for every space we're going to treat it like a split part. Okay, cool. So let's go ahead and test this. Okay, let me full screen this. Okay, the return value from this method gave us some sort of string bracket 5. This is actually a string array, by the way. A string array is a data structure. So if you came from Python or another language, you might have heard of lists. It's kind of like a list. This is like a data structure that stores 5 separate strings. So yeah, sometimes it's necessary to do this. And we're testing. So since we verify that the method does what we want, it might be necessary to maybe store this somewhere and play around with it. Like, this is a sneak peek, by the way. You don't have to know this right now, but I'm going to sneak peek into arrays. This method does return something. You can see here too. It returns a string bracket. String bracket means array or a list. It's like a data structure that contains a sequence of strings. So we could prefix this by saying, hey, store store the return value into a string array. So I'll store it into a string array. I'll call it like I'll call it names. Okay, so I'm saying, hey, declare a string array and name it names. And let me press enter here. Okay, so cool. So now our Jshell has a memory location called names. So if I were to type in names here, it's going to let us visualize it. So names, and yeah, see, it's the same thing. The cool thing about saving it into memory is we can access individual elements now. Like we can say names 0. Name 0 will give us the first string, not the first letter, because we now have a string array. Names 1 gives us Bob. Names 2, 4, and then 5 gives us a exception. 5 gives us an exception because we're out of bounds. It doesn't exist. 0, 1, 2, 3, 4. Yeah, and then 5 goes outside of here, so that's why we got the exception. We'll talk about how to protect against this next week. But yeah, hopefully people are kind of getting a sense on the Jshell. For this class, most of the programming projects should be done as a source code, but sometimes it's necessary to study like small behaviors. Sometimes it's necessary to test methods before using them. So the Jshell is very useful. This will allow you to test them. Okay, hopefully people are okay with that. Any questions about the Jshell so far? Oh, and then quitting. Let's see. I think it's like I think there's a command to quit. I know the keyboard. You can press Control D to quit. What about exit? Okay, cool. Yeah, exit. That's how you exit it. Okay, cool. Any questions about Jshell so far? Okay, cool. Here, let's summarize what we did so far, and then we'll end class from here. All right. This whole week, we really just talked about fundamental data types. We did a bunch of things on numbers. We did some operations on arithmetic. We also did some string manipulation. String, these are non-numeric variables. And then finally, we talked about the Jshell. So these are stuff for this week. Next week, we'll jump. It's going to speed up a bit, quite a bit next week, because we covered the basics for like small syntax. But next week is going to pick up quite a bit because we're going to cover some decisions. I will be modifying this weekly schedule a bit. Once again, this is my first time teaching this as a hybrid, and the pacing is working a little differently. But anyways, next week we'll be doing some branching. It's going to consist of 1.6. I'm going to have a project out soon. It's not going to be gas calculator. I forgot to update this. It's going to be some sort of body mass index calculator. Basically, it's going to be write a program to take 2 inputs and calculate something from it. So if you're okay with doing this class exercise right here, like if you fully understand this class exercise, the next programming project should make more sense. It's going to be called BMI calculator. Okay, that's about it for today, folks. Looks like we're ending a little early. All right. Have a good day, everybody. Thank you, Lutfun. Have a good one as well.